Look at this wonderful graph. Look at this graph. Isn't it neat? It's asking you a lot of questions about this graph. I see here we have a hole. I see we have an asymptote. So let's just get right into it. F of 6. F of 6 means if I were to plug in 6, what value would I get? It looks like if I plug in 6, it kind of hits my graph here at around 6. So I'll say it's 6. I don't know, maybe it's 5. If you have better eyes, you can answer it better. But f of 6 means plug in 6, and what do you get? Well, if I plug in 6, it looks like I get 6, maybe 5, but I'm going to say 6. I already wrote it down. Let's plug in 2. Oh, no, I can't, because this is a vertical asymptote. So me plugging in 2 is impossible. So we'll say that that is undefined or undefined. The limit as x approaches negative infinity. Ooh, what does that mean? That little negative means from the left. So here I am coming from the left. I'm approaching negative 5. And here I am. Oh, but that's a hole there. So at negative 5, I don't have any actual value. But as I go towards it from the left, I am approaching this value, which appears to line up perfectly with 2. So the limit as x approaches negative 5 from the left lines up with 2. Remember, limit is not an exact answer if you're approaching something. It just means that we're basically at 2, so let's just call it 2. This is very similar. We're approaching negative 5 from the right side now. So when we do that, negative 5 from the right, we're hitting the same exact value because it's a hole. So the limit as x approaches negative 5 from the right is also 2. Okay, switch colors because now we're going to focus on approaching 2 from the left. So here I am from the left, I'm approaching 2, and as I approach 2, I'll never hit it, and instead I'll just go down here. What's down there? Negative infinity. The limit as I approach x or at limit as x approaches 2 from the right side, a little positive, means here I am coming from the right, I'm heading to 2, I'm never going to hit 2, but I'm going to go way up here, which means regular infinity. Okay, so usually when you approach a hole, you're going to get the same thing from the left and from the right, but when you approach an asymptote, it all depends on where your asymptote splits up, or where it makes your graph split up, I should say a little bit better. The limit as x approaches negative infinity, which means I am basically moving to the left. So as I move to the left forever and ever and ever, where is my graph going? That way, which is up, which is positive infinity. As x approaches positive infinity, that means I'm moving to the right. My x values are increasing without bound. And as my x values are increasing, my y values, or f of x values, I should say, are also increasing, which means that side is also going to infinity. How about that? Catch me outside, how about that? Now my domain is what numbers am I not allowed to plug in? Let's name those and make sure I don't include those in the domain. I'm not allowed to plug in negative 7 because I have a hole there. I'm sorry, that's a negative 5, not negative 7. And I'm not allowed to plug in regular 2 because I have an asymptote there, a vertical asymptote. So every value seems to be included except negative 5 and 2. So how do I write that out? Well, everything from negative infinity to negative 5, but not including negative 5, union. Everything from negative 5, but not including it, to 2, but not including it, union, and everything to 2 on forever. So there you go. Pretty intense problem. It's like if we're going camping. Intense. Ha ha ha. Like and subscribe.